Okay, today what I want to do is just do a very quick video on a topic that we've just recently covered, which is measurement. What I've got here is I've got an input. This input here is from an audio amplifier. I have a benchtop PSU powering the amplifier with a function generator, and it's pushing a sine wave through to the output through this measurement block. I've got two probes here. Red is measuring the voltage. Probe is set on 1 times. Yellow is measuring the current. Probe is set on 1 times. On the scope here, on the yellow, I've got the probe set on 10 times. Okay, and on the red, I've got the probe set on 1 times. Now, the reason I have the yellow channel set on 10 times is because I'm using a 0.1 ohm metal strip resistor to measure the current that's flowing through the wire, which will have a voltage drop according to Ohm's law of the measured amount, where V over R equals I, so the current can be measured through this strip here. Now on the scope, what we're seeing is cyclic RMS and mean values. Okay, so you can see on channel 1, on the top one, which is the red channel, we have 4.3 volts measured RMS. The mean is only 100 millivolts, 123, 130, 120, so it's bouncing around just a little bit. So it's only several hundred millivolts that's being measured. Now, something that we've covered, and this is the reason I wanted to put it into the video, is what the mean is doing is it's taking the numbers above. So what we talked about that the scope is measuring points, millions of points at a time within the, and I'll show you, so the buffer. So this is the scope's buffer. Okay, now there's millions of points measured in here, but the points are only taken every now and again to write on the screen. So all the points are not displayed, it's only a series of part of the points. So there's millions of points that draw these waveforms. Okay, and because both probes, both the red probe and the yellow probe, are both set to the 0 gradical line here on the scope, we see numbers above, so millions of points above the 0 line, and at the same time we see millions of points below the 0 line. Okay, so what we're seeing here is we're seeing a series of points that are being measured. Okay, we'll zoom in a bit more, and all of these points drawn on the screen represent the waveform. So the waveform that's being measured from here, the voltage and the current, are being displayed over here. Okay, so when you have, say we've got 1 point at the top and it's 1, okay, so it's measured 1, and then we've got 1 point at the bottom and it's -1, and what we're seeing there is 1 plus -1 equals 0, so that will be the 0 line. So what the scope's saying is for the mean value, is there's just about as much positive numbers as what there is negative numbers. So the mean that's being measured there, 192, 179, it's jumping around because the scope measurement points are different every time it captures and calculates an average, a mean. So that's mean. The mean, or the average, is how much is going forward and how much is coming back. Now we need to remember that AC is an alternating current, so it has both negative and positive values. If we're dealing with DC, we wouldn't have any negative values, but it would all be positive values, and I'll show you that in a minute. Okay, So that's why mean is different. Okay, we can see RMS. RMS takes the negative values, it turns the negative values into positive values, and all the forward current and backward current, or forward voltage and backward voltage, are all positive. So this is the complete positive numbers being measured by the scope. Cyclic RMS. There's an equation on the forum that I've put up. Okay, so down here, current RMS. Okay, we take that voltage reading, or that reading. So it's actually 1 ampere, 1.046 amperes RMS. And again, mean, it's only 179 because it's measuring almost as much forward current as what there is backward current. Okay, so the negative numbers and positive numbers cancel each other out, and that's why it's mean, because there's the mean forward value is just slightly greater by only a few hundred millivolts than what it is backward. So we have a slightly uneven waveform, if you like. Okay, so powering a load with AC, measuring through the measurement block, that's why we get different numbers. Okay, so the mean and the RMS are important to know about. It's important to know about these values. It's important to know how they work, so that you can actually look at the scope and say, okay, well, this is what's happening. So RMS would normally be used for AC voltage in a linear load. For a non-linear load, you would typically look at the mean, and you would look at the forward current and the backward current. So you would have both negative numbers and positive numbers that you'd have to think about. Okay, so it's not that hard, but you sort of looking at the scope, if you're sort of fresh and new, it is very easy to overlook these things. Just sort of jumping on a piece of paper and working these things out sometimes is a good thing to do. Alright, more in a minute. Okay, so we're back again. We've got the same measurement block. This time we've got DC, a DC current applied to the measurement block. All the same rules apply. We've still got the same resistor, scope probe set on the same, but this is what we see on the scope. Okay, now what we're seeing here is just the DC voltage and the DC current. Okay, so you can see down the bottom the mean and the cyclic RMS are almost the same. It's because the current is going in one direction. Okay, we don't have any current coming back. We don't have any spikes or anything like that on the negative side of the scope trace. It's all positive current. Okay, so RMS, mean are the same down the bottom. Okay, if we look at the top, the voltage is almost exactly the same as well. Sometimes it does vary a little bit. RMS and mean are the same, approximately the same values for straight DC. For a linear load, which means it's going to carry a linear current, it's not going to change once the load is powered up. We're going to have a current. If the voltage doesn't change, we're going to have a current that stays the same. Okay, as soon as we apply the voltage, the current will zoom up as fast as it can, and obviously the current will stay pretty much a straight line. There might be some ripple in it sometimes. There might be the odd little up or down or something like that due to line issues and stuff like that, or interference, but basically it's going to be the same. So you can see measurements for DC with a linear load are pretty much the same between mean and cyclic RMS. Okay, remember, it's got to be a linear load. If it's a non-linear load, we're going to see changes in the DC current and DC voltage where they may become negative, and in that case, if we see negative, it means it's coming back to the source. The current and or voltage is being delivered back to the source at a negative flow, so it's traveling back to the source and trying to power the source, and that would be a non-linear load.